OB is equal to OC is equal to CB, all are equal, therefore OBC is a equilateral triangle. When R is equal to 75, L is equal to 10 centimeter. Again, when R is equal to 75, LRH is equal to 15. The value of cos x lies between -1 and +1, and similarly the value of sin also lies between -1 and +1. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding few more problems based on finding the arc length of a sector and also finding an angle whenever an arc length is given, and some trigonometrical ratios, okay, trigonometrical functions. Now let us start with the first problem. The first problem is a wheel makes 360 revolutions in 1 minute. Through how many radians does it turn in 1 second? This is very simple problem and important problem. So a wheel makes 360 revolutions in 1 minute. So therefore number of revolutions in 1 minute is equal to 360. This is given. So in 1 minute, so it will cover 360 revolutions. This is given condition. This is given. Okay. Now convert into 1 second. Therefore the number of revolutions in 1 second. Therefore the number of revolutions in 1 second is equal to, so in 1 second this is 360 divided by 60, right? 360 by 60, that is equal to 0 gets cancelled, this is equal to 6. So it will make 6 revolutions in 1 second. Okay. Now but in one revolution the angle traced is 360 degrees. So in complete one revolution it will cover an angle of 360 degrees, right? So that is nothing but 360 degree, or it is equal to 2 pi radians. So therefore in one revolution it will makes an angle of 360 degrees or 2 pi radians. 360, or that is equal to 2 pi radians. So what is required to find now? A wheel makes 360 revolutions in 1 second. Through how many radians does it turn in 1 second? Okay. Now for 1 second it will make 6 revolutions. So therefore the angle traced in 6 revolutions is equal to 6 into 2 pi. Therefore the angle traced in 6 revolutions is equal to 2 pi into 6, that's equal to pi into 12, that's nothing but 12 pi. It will make 12 pi. So the angle traced in 6 revolutions is 12 pi. So therefore the angle traced in 1 second is equal to 12 pi radians. That's it. That is simple problem. See here. So the angle traced in 1 revolution is equal to 12 pi radians. Very simple problem it is. Just find out the number of revolutions in 1 second, because here the number of revolutions in 1 minute is 360 degrees, that is given. So therefore the number of revolutions in 1 second is 360 divided by 60, that's equal to 60. So the number of revolutions in 1 second is 60. So for one revolution it will cover an angle of 360 degree, that is nothing but 2 pi radians. So therefore for 6 complete revolutions it will make an angle of 6 into 2 pi, that's equal to 12 pi radians. That's it. So it will cover an angle of, so in 1 radians, in 1 second it will cover an angle of 12 pi radians. That's all. This is a simple problem and important problem. Hope you followed. Hence the angle traced in 1 second is 12 pi radians. Now let us come to the next problem. Now what is the problem given? Find the degree measure of the angle subtend at the center of a circle of radius 100 centimeters by an arc length 22 centimeters. Use pi is equal to 22 by 7. So, this is also a very simple problem. Now, what is given here? Find in degrees, degree measure the angle subtend at the center of a circle. Theta is equal to question mark, and given radius r is equal to 100 centimeters by an arc length of an arc L or S is equal to 22 centimeters, and the value of pi is equal to 22 by 7. So, this is given. See here, suppose if it makes an angle like this, this is an angle theta, this is the arc length S, this is radius R, then we know S is equal to R into theta. So, what is given here? R is given, R is equal to 100, and S is also given, S is equal to 22 centimeters. Then this is required to determine, theta is to be determined, that is. Now, what is the formula? S is equal to R into theta, S is equal to R into theta, or theta is equal to S divided by R. What is S? S is equal to 22 and divided by R. What is R? R is equal to how much? 100. So, if you simplify this, this is nothing but divide by 2, 11 by 50. Now, convert this into radians. So, therefore, theta is equal to 11 by 50 into pi by 180. Simplify this. Since this can be written as 11 by 50 into, since the value of pi is 22 by 7, it is given 22 by 7 divided by 180. 63 by 5. Now, after simplification, we will get 63 by 5. So, divide this. This can be written as 5 12s are 12 5s are 30. Then what is remaining is 3. So, this can also be written as 12 degrees and 36 minutes. That's all. So, if you simplify this, you will get 12 degrees and 36 minutes is the simplified answer. That's it. So, if you divide, how much? 63 by 5. 63 by 5 approximately will get 12.6. Okay, that's nothing but 12 degrees. 6 into 6 is 36 minutes. That's it. Let me explain once again. So, find the degree measure of the angle subtend at the center of a circle by a radius of 100 centimeter by an arc length of 22 centimeters. Now, here what is given? S is given, arc length S is nothing but 22 centimeters, and radius is given 100 centimeters. What is required to find is theta. Since we know S is equal to R into theta, the relation between S, R and theta is arc length S is equal to R into theta, or theta is equal to S by R. Substitute S is, S value is 22 divided by R is the radius 100, 22 by 100 is nothing but 11 by 50. Convert this into radians, and that is 11 by 50 into pi by 180 degrees, that is nothing but 11 by 50 into pi values 22 by 7 divided by 180, that is equal to 63 by 5. So, 63 by 5 if you divide, you will get 12.6, 6 into 6 is equal to 36. So, 12 degrees 36 minutes. So, 0.1 degree is equal to 6 minutes, 0.6 degree is equal to 6 into 6, 36 minutes. So, you will get 12 degrees 36 minutes exactly. So, the value, the angle in degrees is 12 degrees and 36 minutes, which is the required answer. Okay. Now, let us come to the next problem. In a circle of diameter 40 centimeters, this important problem, a circle of diameter 40 centimeters, the length of the chord is 20 centimeters. Find the length of the minor arc of the chord. So, here the diameter is given. Diameter is equal to 40 centimeters means radius is equal to diameter divided by 2. So, radius is equal to diameter by 2, that is 40 by 2 is equal to 20 centimeters. So, let us construct a diagram. This is the diameter, AB is the diameter which is of 40 centimeters, and now if you divide by 2 we will get OB is equal to OC is equal to 20 centimeters. So, given diameter AB is equal to 40 centimeters, therefore, the radius OB is equal to 20 centimeters and the chord BC is also equal to 20 centimeters. Here, since OB and OC and CBR are equal. They are equal. So therefore this is an equilateral triangle. So OBC is an equilateral triangle. Okay. Since all sides are equal, therefore OBC, that is OBC is an equilateral triangle. So equilateral triangle means each angle is equal to 60 degrees. Therefore, from this triangle OBC, angle COB is equal to 60 degree. 60 degree, this is nothing but pi by 3 radians. 60 degrees, or this is equal to pi by 3 radians. Now, here theta is equal to pi by 3. Now, what is required to find? So, find the length of the minor arc of the chord. So, we have to find the length of the minor arc of the chord. Here, radius is given, chord length is also given, and the angle theta is also given. Okay. So, what is required to find is the arc BC. BC is equal to, yes, arc length. So, therefore, to find BC is equal to arc length, that's equal to, yes, this is question mark. Now, since we know what is the formula, S is equal to R into theta. What is the radius? Radius is equal to 20 centimeters into theta is equal to pi by 3 radians. So, this is equal to 20 by 3 into pi is nothing but 22 by 7. So, this is equal to, if you multiply 20 into 22 divided by 7 3s are 21. So, this is equal to 440 divided by 21 is equal to 20.95 centimeters. This is the required answer. That's it. Okay. Listen to me. Now, just let me explain once again. So, here what is given? In a circle of diameter, AB is the diameter 40 centimeters. The length of this chord BC is equal to 20 centimeters. Find the angle of minor arc of the chord. This is to be determined. The minor arc BC is to be determined. Now, what is given? Given the diameter AB is equal to 40 centimeters. So, therefore, the radius is equal to diameter by 2 means radius OB is equal to 20 centimeters and the chord BC, this BC is equal to 20 centimeters. Now, here OB is equal to OC is equal to CB, all are equal, therefore, OBC is a equilateral triangle. Since all sides are equal, therefore, it will form an equilateral triangle. From equilateral triangle, angle COB is equal to 60 degree, each angle is equal to 60 degree, that is nothing but pi by 3 radians. Now, to find, what is required to find is to find BC. BC is nothing but the length of an arc of the sector, yes, that is nothing but the minor arc of the chord. BC is the minor arc of the chord, that is equal to S. Since what is the formula? S is equal to R into theta. R is 20 into theta is pi by 3. 20 by 3 into pi value is 22 divided by 7. So, 20 into 22 is 440 divided by 7 3s are 21. 440 by 21 is 20.95 centimeters. So, therefore, the length of a minor arc of the chord is 20.95 centimeters, which is the required answer. Okay, hope you followed. Now, let us come to the next problem. So, if in two circles, there are two circles, arcs of the same length subtend angles of 60 degrees and 75 degrees at the center, find the ratios of their radii. The same problem, same type problem we did in the last class, same type problems. Let us consider what is given here. If in two circles, arcs of same length subtend an angle of theta 1 is equal to 60 degrees and theta 2 is equal to 75 degrees. At the center, find the ratios of their radii. R1 is to R2 is to be determined. That's all. If R1 and R2 are the radii for the first and second circle, theta 1 and theta 2 is the angle of intersection for the first and second circle, then what is required to find is R1 is to R2 provided theta 1 is equal to 60 degrees and theta 2 is equal to 75 degrees. Let R1 and R2 are the radii. R1 and R2 are the radii. Theta 1 and theta 2 are the angle. Theta 1 is equal to 60 degrees means pi by 3 radians and theta 2 is equal to 75 degrees. This is equal to 75 into pi by 180. This is equal to, this can be written as 5 pi by 12 radians. You can divide 5 pi by 12 radians. Suppose if L is the length of each arc or S is the length of an each arc, then L is equal to R1 into theta 1 is equal to R2 into theta 2. This is given. So, what is required to find is R1 divided by R2 is equal to, we will get theta 2 divided by theta 1. This R1 by R2 as it is, R1 by R2 as it is equal to, what is theta 2? Theta 2 here we have, theta 2 is 5 pi by 12. 5 pi by 12 divided by theta 1. The value of theta 1 is pi by 3. Pi by 3. So, this can be written as 5 pi by 12 into 3 divided by pi. So, pi and pi gets cancelled. Then what is left is 3 4s are 5 by 4. So, R1 by R2 is equal to 5 by 4. So, therefore, the ratio R1 is to R2 is equal to 5 is to 4. That's it, 5 is to 4, correct. So, the required ratio R1 is to R2 is equal to 5 is to 4 is the required ratio. So, the required ratio is 5 is to 4. See here, let me explain. What is given? In two circles, same length, arc of same length means S and L are same. So, that is the arc length S is same for both the circles. Subtend an angle of 60 degrees and 75 degrees at the center. Find the ratio of their radii. Suppose if R1 and R2 are the radii of two circles, first circle and second circle, theta 1 and theta 2 are the angle of intersection for the first and second circle, then what is given? Theta 1 is equal to 60 degrees, theta 2 is equal to 75 degrees. Convert theta 1 into 60 into radians, 75 into radians. So, that is pi by 3 radians is called 60 degrees and 75 degrees nothing but 5 pi by 12. 75 into pi by 180, that is equal to 5 pi by 12. If R1 and R2 are the radii, then we have S is equal to R into theta, S is equal to R into theta, or L is equal to R into theta. So, L is equal to R1 theta 1 is equal to R2 theta 2. Substitute here R1 by R2. R1 by R2 is equal to theta 2 by theta 1. Since R1 by R2 is equal to theta 2 value is 5 pi by 12 divided by theta 1 is pi by 3. Transfer this to the numerator. 5 pi by 12 into 3 by 5. Pi and pi gets cancelled. 3 4s are 12. 5 by 4. So, therefore, the ratio R1 is to R2 is 5 is to 4. So, hence the required ratio of their radii is 5 is to 4. 5 is to 4 is the ratio of the radii. That is the required answer. Hope you followed. That's it. Okay. Now, let us come to the next problem. Find the angle in radians. Find the angle in radians through which a pendulum swings. If its length is 75 centimeter and the tip describes an arc length of 10 centimeters and 15 centimeters. Two questions are given here. So, find the angle in radians through a pendulum swings its length, arc length of 75 centimeters. Here what is given? Let us come to the first one. So, length is 75 centimeter and the tip describes an arc length of 10 centimeters and 12 centimeters. Okay. Now, first one. When L is equal to 10 centimeters, this R is equal to 75 centimeters. First, this is R is 75 centimeter, L is equal to 10 centimeters. What is required to find? Theta is the question mark. So, S is equal to R into theta. Theta is equal to S by R. What is S here? S is equal to, we have the value of S is nothing but L. S is 10 divided by R is equal to 75. 10 divided by 75. So, this is 5 2s are 5 15s are 15 5s are 75, 2 by 5 radians. So this can also be written as 2 by 15 into 180 by pi degrees, conversion into degrees. So if you simplify, this is 2 by 15 into 180 divided by 22 by 7, this goes to the numerators, degree. So if you simplify this, you are going to get it as, so this is 2 11s are again 15 1s are 15, then 15 2s are 30. So if you simplify, you will get 12 by 11 into 7. So this is 12 into 7, 84 divided by 11 degrees. So if you convert this 84 by 11, if you divide 84 by 11, 7.6 something you will get. So this can also be written as 7 into 7 by 11 degrees. So 11 7s are 77 plus 7 is 84 divided by 11. So 7 by 11 degrees is the first answer. Okay. Now let us come to the second one. So what is R? R is equal to, R is 75 as it is, and this is the value of S. S is equal to 50. We know that since S is equal to R into theta, theta is equal to S by R. So what is S? S is equal to 15 divided by 75. 15 5s are 75. 1 by 5. So theta is equal to 1 by 5. So convert this into degrees. This is radians. So this is 1 over 5 into 180 divided by pi degrees. Same. So this is nothing but 1 by pi into 180 divided by 22 into 7 degrees. Simplify this. So this is equal to 126 by 11 degrees. So after simplification, if you simplify this, what is the answer we are going to get? 16 degrees, 2 minutes, 11 seconds. That's it. Simplify this. So the simplified answer for this is 16 degrees, 2 minutes and 11 seconds is the simplified answer for this. Okay, that's it. So here, in the first case, what is given here? The pendulum swings its length. Length is given, arc length S is equal to, S is given to be 75 for both the cases. When R is equal to 75, L is equal to 10 centimeter. Again, when R is equal to 75, L or S is equal to 15. So when S is 15, R is equal to 75, we have S is equal to R into theta, or theta is equal to S by R. Theta is nothing but S divided by R means 10 by 75, that's equal to 2 by 15. So convert this into degrees, you will get 7 and 7 by 11. Whereas when R is equal to 75 and S is equal to 15, we have S is equal to R into theta, theta is equal to S by R, that is 1 by 5, we will get theta is equal to 1 by 5 radians is converted into 16 degrees, 2 minutes and 11 seconds. That's it. Hope you follow. So these are few types of problems based on length of an arc of a sector. Okay. Let us come to the trigonometrical functions. Now trigonometric functions, this is very important concept. Now you might have been studied in your previous classes the trigonometrical functions like sine of angle theta, sine theta or sine x, cosine of angle theta, cos theta or cos x, tangent of angle theta, tan theta, cotangent of angle theta is called cot theta, secant of angle theta is called secant theta, and cosecant of angle theta is called cosecant theta. So sin theta, cos theta, tan theta, cot theta, secant theta, cosecant theta are the trigonometrical functions you might have been studied, and also the definitions. You might have been studied in definition. Sine of angle theta, sin theta is always equal to opposite side divided by hypotenuse side, right? Opposite by hypotenuse is sin theta, cosine of angle theta is cos theta by hypotenuse, tangent of angle theta is opposite by adjacent, and cotangent is adjacent by opposite, secant is hypotenuse divided by adjacent, and cosecant of angle theta is hypotenuse divided by opposite. You might have been studied all those things in previous classes. The same we are going to study once again here. Okay. Now let us we have studied the trigonometrical ratios of acute angle as the ratio of sides of a right angle triangle. Now, to define the trigonometric ratios of any angle in terms of radian measure as trigonometric function, we are going to consider a unit circle. Consider a unit circle. So, consider a unit circle with center as O. O is the center of the circle of the coordinate axis. Let P, A comma B any point, P, A comma B any point on the circle where OA, this OM is equal to small a and PM is equal to small b. OM is equal to small a and PM is equal to small b. P, A and B are the coordinate. Now that is, let P, A comma B any point on the circle with an angle AOP is equal to x radians or theta radians. The length of an arc AP, the length of an arc, this arc AP is equal to x. So therefore, here the distance OM is equal to small a and PM is equal to small b, and this is a unit circle of radius unit, 1 unit. Therefore, OP is equal to 1 unit. OP is equal to 1 unit. Now you can define, as I told, sine of angle theta. Here, suppose if I define sine x is equal to, what is sine x? Sine x is equal to, opposite. Opposite is PM divided by hypotenuse is OP. So what is PM here? PM is equal to B and OP is equal to 1. This is equal to small b. Sin x is equal to b, you will get. And similarly, to find out cos x is equal to adjacent. Adjacent is OM divided by hypotenuse is OP. What is OM? OM is equal to small a, hypotenuse is 1, this is equal to small. So cos x is equal to 1. So we can define cos x is equal to A and sin x is equal to B. Since OPM, this OMP is a right angle triangle, we have the formula for this. OA square plus OM square plus MP square is equal to, by Pythagoras theorem we can write OP square is equal to OM square plus MP square. So therefore you can write 1 is equal to A square plus B square. A square plus B square. We can say 1 is equal to A square plus B square, means therefore 1 is equal to sin square x plus cos square x. Okay. Now, so A square plus B square is equal to 1 or cos square x plus sin square x is equal to 1. So here, now we can define sin x is equal to B and cos x is equal to A, then A square plus B square is equal to 1 using Pythagoras theorem. Since this is a right angle triangle, so sin square x plus cos square x is equal to 1. So this is one of the important identity you might have been studied. Now the few important concept which you have studied in your previous classes are the trigonometrical functions are. So suppose if you consider a right angle triangle, so this in a triangle, suppose if this is a triangle ABC, this is a 90 degrees, then this is angle theta. The side opposite to 90 is an hypotenuse. The side opposite to theta is an opposite side. In between opposite and hypotenuse, it is an adjacent side. Now you might have been studied in your previous classes. The 6 trigonometrical functions are sin theta is equal to opposite divided by hypotenuse. What is opposite? AB divided by AC, right? And similarly, cosine of angle theta, cos theta is equal to adjacent side divided by hypotenuse side. Adjacent side is nothing but BC divided by AC. And the tangent of angle theta is called tan theta is equal to opposite divided by adjacent side. That's equal to AB divided by BC. Similarly, cotangent of angle theta is called theta is equal to adjacent side divided by opposite, adjacent by opposite, BC by AB. BC divided by AB. And similarly, secant of angle theta, secant theta is equal to hypotenuse divided by adjacent side, hypotenuse divided by adjacent. What is hypotenuse? AC divided by BC. And finally, the cosecant of angle theta, cosecant theta is equal to hypotenuse by opposite side. What is hypotenuse? AC divided by AB. So this is AC divided by AB. So these are the 6 trigonometrical functions you might have been studied in your previous classes. Just recall it, that's it. So what is sine theta? This is order: sine, cos, tan, cot, secant and cosecant. Further we have so many reciprocal relations and the quotient relation. So sine theta opposite by hypotenuse, AB by BC, cos theta adjacent by hypotenuse, BC by AC, tan theta opposite by adjacent, cot theta adjacent by opposite, secant theta hypotenuse by adjacent, cosecant theta hypotenuse by opposite. So once if you know sine and cos, what is sine theta? Opposite by hypotenuse. Then for cos there is no opposite, only adjacent. Cos theta adjacent by hypotenuse, sine theta opposite by hypotenuse, cos theta adjacent by hypotenuse. Now for tan theta, so to find tan theta, if you divide this, if you divide, you will get, so hypotenuse gets cancelled, you will get opposite by adjacent as tan theta. So if you divide sine by cos, sine theta by cos theta, sine theta by cos theta. What is sine theta? Opposite by hypotenuse, and cos theta is equal to adjacent by hypotenuse. These two gets cancelled. You will get opposite by adjacent. This is called a tan theta. So if you reciprocate tan theta, adjacent by opposite, you will get cot theta. If you reciprocate secant theta, hypotenuse by adjacent, you will get secant theta. If you reciprocate sine theta, you will get cosecant theta as hypotenuse by opposite. So okay. Now further you might have been studied regarding the quotient relations. So what are the quotient relations? Tan theta is also equal to sine theta divided by cos theta, and cot theta is equal to cos theta divided by sine theta. Right. Okay. And you might have been studied the reciprocal relations also. What are the reciprocal relations? Sine theta into cosecant theta is always equal to 1. That is first and last. Sine theta into cosecant theta. So sine theta, here sine theta opposite by hypotenuse into cosecant theta, hypotenuse divided by opposite, these two gets cancelled, this is equal to 1. So therefore if you want only sine theta is equal to 1 by cosecant theta, or if you want cosecant theta is equal to 1 by sine theta. So sine theta is equal to 1 by cosecant theta is equal to 1 by sine theta. Similarly, cos theta is also equal to 1 by secant theta is equal to 1 by cos theta. Tan theta is equal to 1 by cot theta, or cot theta is equal to 1 by tan theta. So these are the reciprocal relations. So these are all the trigonometrical functions of sine, cos, tan, cot, secant, cosecant, and their reciprocal relation and quotient relations that you might have been studied in your previous classes. Right. Now let us come to signs of trigonometrical functions. Now here from this diagram I can write the value of first sin x. Sin x is equal to opposite by hypotenuse, that is b by 1 is equal to b. Similarly, cos x is equal to, cos x is nothing but a by 1 is equal to a. For sin of minus x, let us come to the sin of minus x. For this triangle, sin of minus x is equal to, this is b minus b divided by 1, that's equal to minus b. Similarly, cos of minus x is equal to a divided by 1 is equal to a. When for the first point p, sin x b and cos x is a. Similarly, cos of minus x is equal to, a by 1, that's equal to a. What is a here? This is equal to cos x. So cos of minus x is equal to cos x. Similarly, sin of minus x is equal to, what is sin x? From this? Sin x is equal to minus b. This is minus of sin x. So therefore, cos of minus x is equal to plus cos x, whereas sin of minus x is equal to minus sin x. That means, since for every point p on a comma b on the unit circle, this A value always lies between -1 and +1, and B also lies between -1 and +1. So therefore, -1 less than or equal to A less than or equal to +1, and similarly -1 less than or equal to B less than or equal to +1. So that means the value of cos x lies between -1 and +1, and similarly the value of sin also lies between -1 and +1 for all the values of x. That is denoted as -1 less than or equal to cos x, which is less than or equal to 1, and -1 less than or equal to sin x, which is less than or equal to 1. So here the value of cos x is positive when x is replaced by -x, and sin of -x is minus sin of x. So therefore the value of x -1 less than or equal to sin x, which is less than or equal to 1, and -1 less than or equal to cos x, which is also less than or equal to 1. So these are for all values of x. These are the signs. Now let us come to this. Now in first quadrant, that is from 0 to 90 degrees, 0 to 90, 0 to pi by 2, 0 less than x less than 90 degree, 0 less than x less than 90 degrees, then A and B are both positive. So A and B are both positive. So in first quadrant, sin x as well as cos x, both sin x is positive, cos x is also positive. A and B is positive is nothing but A. What is A? A is cos x and sin x. Okay. Now in the second quadrant, 90 less than x less than pi means pi by 2 less than x less than pi means 90 less than x less than 180. So if the value of x is in between 90 to 180, A is negative and B is positive. A is negative. A is negative means cos is negative and sin is positive. So in second quadrant, here we have cos as negative whereas sin as positive. Whereas in the third quadrant, pi less than x less than 3 pi by 2, that means 180 to 370 degrees, A and B are both negative. That means A is negative, B is negative means both sin x is negative, cos x is also negative. Sin and cos both are negative. So in the fourth quadrant, 270 to 363 pi by 2 less than x less than 2 pi, A is positive and B is negative. So A is positive and B is negative. B is negative. So that means positive means cos x is positive and sin x is negative. So x is positive for, see, therefore x is positive for 0 less than x less than pi and negative for 0 less than x less than 2 pi. Similarly, cos x is positive for x is in between 0 to pi by 2 and negative for pi by 2 less than x less than 3 pi by 2, and also positive for 3 pi by 2 and x less than 2 pi. That means, so depending upon this, we can put this in the form of a table, whether sin x is positive in first quadrant, second quadrant, third quadrant, fourth quadrant, and similarly what is the condition for cos x in first, second, third and fourth quadrant. So these are how we are going to assign the signs for sin x and cos x in first and second quadrant. Now let us come to this. So here the trigonometric functions, depending upon those values, the trigonometric functions for different quadrants are like this. In the first, second, third and fourth quadrant, in first quadrant sin x is positive, sin is positive, then cos x is also positive, tan, cot, all are positive in the first quadrant. In first quadrant all are positive, all trigonometrical ratios are positive. Whereas in second quadrant sin x is positive and the reciprocal of sin x is cosecant x is positive, the remaining two are negative. Only sin and sin x and cosecant x are positive, remaining are all negative. Whereas in third quadrant, tan x and cot x, tan theta and cot theta are positive, tan x and cot x are positive, remaining are all negative. Hence in the fourth quadrant we have cos x is positive and the reciprocal of cos is also positive, that is secant x. So therefore this is abbreviated as ASTC. All students take copy, that we will study in the science of while doing the trigonometrical ratios of standard angles and allied angles. All students take copy. Okay. Now here in first quadrant all are positive. In second quadrant only sine and the reciprocal is positive, whereas in third tan and reciprocal of tan is positive, whereas in fourth quadrant cos and the reciprocal of cos is positive. So these are the trigonometric functions in different quadrants, the signs of trigonometric functions in different quadrants. So in first quadrant, for sin x is positive in first and second quadrant, negative in third and fourth quadrant, whereas cos x is positive in first quadrant and fourth quadrant, negative in second quadrant and third quadrant, whereas tan x is positive in first quadrant and third quadrant, negative in second and fourth quadrant. Similarly, cosecant x, secant x and cot x. So these are the signs. So here, based on this, so we can conclude that in first quadrant lies from 0 to 90, second quadrant 90 to 180, and third quadrant 180 to 270, and fourth quadrant 270 to 360. So in first quadrant, sine all trigonometrical ratios are positive, sine, cos, tan, cot, secant, cosecant, whereas in the second quadrant only sine is positive and the reciprocal of the sine is cosecant is also positive. So, and whereas in third quadrant 180 less than x less than 270 degrees, tan x and cot x are positive, remaining are negative. That is, in third quadrant sin x and cos x are negative. And whereas in the fourth quadrant 270 to 360 degree, we have only cos is positive and sin is negative. Hence, therefore, x is a positive for all 0 less than x less than pi and negative for pi less than x less than 2 pi. Similarly, cos x is positive for 0 less than x less than pi by 2 and negative for pi by 2 less than x less than 3 pi by 2 and also positive for 3 pi by 2 less than x less than 2 pi. Hence, we can say that the values of x here is cos x, therefore, minus 1 less than or equal to sin x less than or equal to 1 and minus 1 less than or equal to cos x less than or equal to 1 for sin x and cos x. Using that, we are going to distribute the signs. This is how the signs conventions for all the trigonometrical ratios in first, second, third and fourth quadrant. That's all. So in general, in first quadrant all trigonometrical ratios are positive, whereas in second quadrant only sine is positive, in third quadrant tan is positive, and in fourth quadrant cos is positive. That is why it is A, S, T, C. So simple concept is all students take coffee, all silver teacups. So this is how we can remember. Okay, that we will discuss in the next class, no problem. Hope you followed this. So that's all regarding today's session. Let us meet with a different concept in the next class. Thank you very much.